we did.
Sure. No worries, no worries. We'll basically discuss about the same. If like required, I will basically schedule some classes because if the electricity is of 9 marks, so it means that there are mostly numericals that you are going to have in your periodic. So what we will do is that I will discuss some numerical approach in the extra class so that you can attempt those. Okay.
Yeah, so it
But
did say that numericals will be like focus more on numericals as numericals will contain more marks and more numericals are more likely to come.
that is the thing because 9 marks is not that much like a big portion in which they could ask you the conceptual question. Ultimately, they would be very basic concept. If conceptual question would be there, that would be of only very basic concept. Most of
So
the portion would be from the numerical. So I'll basically discuss the approach about the same. Okay, and basically in this class we are going to start the electricity chapter as well. So I'll basically continue the detailed syllabus in the back. Okay.
so it was like about only two numericals, only two subjective questions would come.
Only two subjective questions would come. So only conceptual or numerical. Because subjective can be both types.
Like the written stuff, not the.
You are okay. So basically, the remaining questions would be MCQ. You are is that your
But basically, Sir said that focus more on numericals as numericals will count more marks, and then the electricity chapter is apparently hard, so we have to focus more on it.
that's what I'm saying. That is what. Check.
And then
Go.
November 25th, uh,
Uh,
our
pre-board
uh, pre-board one starting.
25th of November.
Yeah, 25th or 20 November. They didn't say it yet. Teachers
20th
told.
November. Okay, okay. Now, like till that portion will be done with the electricity. And magnetics is a chapter which requires only 2 or 3 classes. Now, the magnetics is very small. It's the smallest chapter. Like magnetics was basically like almost similar to electricity as compared if we talk about the theoretical portion. But after COVID, the CBSE has reduced the majority of the portion. Like it scrapped all the main portion like AC generator, DC current, AC current, and induction, electromagnetic induction. These were the main topics which were complete like a little bit hard to understand, a little bit, but these topics are completely omitted. So only very, very basic portion is left. That is the direction of magnetic field and your left hand control. Like only these two topics are important. So
Okay.
magnetic is not that much tough. The main topic or main chapter is basically tough. That is electricity and light. And we have completed the light itself, human eye as well. In this class, we are going to start the electricity. Sure. Hello, Mariam. Assalamu alaikum. Hello, Aisha. Hello, Abdul. Assalamu alaikum. How are you, bacho?
Walaikum salam, sir. Sir, how are you?
I'm good. I'm good. Thanks for asking. Okay, so just a second. Okay, so everyone, please switch on your videos. Aisha, Mariam, and Abdul. Aisha, Mariam, and Abdul, please switch on your video. Okay, that's good. Abdul and Mariam, what happened? Abdul, are you there? Abdul, please switch on your video. Check. Yeah. Okay, so in this class we are going to start the electricity chapter, right? So electricity chapter is a chapter which has the most number of numericals. You can see the variety of numericals. Like light was a chapter in which numericals were there, but electricity is way ahead of light chapter, right? So in this chapter, you have to study hard, you have to practice, revise, and all that. Mariam, your screen is black, so please check your camera. ठीक है। तो yeah, please check it. ठीक है। And ठीक है, so and basically it's a request to all of you that please do not miss the electricity classes, because this is a very important chapter. This is a very lengthy chapter. It will take almost like 7 to 8 or 9 classes to complete this chapter, right? So yeah, so you have to be patient, but the weightage is very very high for this chapter. There everyone, Aisha, Abdul, Mariam and Zainab. Chalo. Now let's start the class, okay, with the basics. So the first topic that we are going to discuss is the electric charges. Okay, so electric charge is the first topic that we are going to discuss about the in the the electricity chapter. Right. So first of all, please do let me know everyone that how many charges are there? How many types of charges are there?
Two charges.
Yes, Aisha?
Two charge.
Two charge. Zainab, Abdul, Mariam. What about you, Bacho? Aisha said two. Okay, Zainab said two. Mariam said two. Abdul? Okay. So basically, two charges are there. Two types of charges are there. That is, first is positive charge. Second one is negative charge. Right. So let's write down the thing. Okay.
Should we write this down?
Yes, I is Zainab. Are you saying something? Your voice low. Please repeat.
Should we write this
Ah,
down?
yes, yes, yes. You have to write it. These are the starting points. There are two. First one is positive charge. That the name for that positive charge is proton. Okay. B part is negative charge. Electron. That is electron. Okay. There are two types of charge. The first one is called proton. So in the ninth standard, there was a chapter in which you have studied atoms and molecules. And in the atoms, there are three things, that is electrons, protons, and neutrons, right? So same here, protons and electrons are the two types of charges that is present, and we are going to study these types of charges. Okay. As with the name suggesting, proton means positive, negative means electron. Okay. Chalo, that's great. Now let's understand okay. So basically, first of all, we have to study the basic properties of charges. Like what are the basic properties? Like why do they repel? Like similar charges repel each other, unlike charges. Oh, sorry, like charge. Sorry, you can say the opposite charges attract each other, right? So now let's understand this thing. Okay. So first of all, similar charges repel each other. Repel means it basically push away, right? So let's understand this before. First of all, the thing that I'm going to explain is not a 10th standard topic, but still that will give you the insight what happens when you take two same charges towards each other, right? So suppose that this is again. So this is a positive charge. So this is a positive. So basically, let's take an example to understand this positive charge. So basically, suppose that there is a heater in a room. So there is a heater in a room. What will you observe? What will you experience if you enter that room in which a heater is placed and heater is switched on basically?
You will feel the heat.
Heat, there will be a warmth in the room,
Mm.
right? So similarly, so it means that if the heater is placed in a room, it means that there will be some heat. It means that due to that heater, a kind of warm area is produced, right? Suppose that room is basically very big, but you will feel heat around a certain region, very near to the heater, right? Again, similarly, when a positive or basically when a charge is there, whether it's positive or negative, it basically makes a field around itself that is called electric field, right? It's a similar kind of region to heat, but here it experiences the electric field, basically electric charge, you can say force, okay, electric force. So basically, this electric charge, positive electric charge fields are outward. It means they're away from the charge. It means that it is going outward, right? So for one more thing, these lines are imaginary lines. These lines are called electric field lines, and but these lines are imaginary. So how do we get to know that whether these are outwards or inwards? Due to the experiment, right? So those experiments are in a 12th standard. You don't have to study right now. I'm just telling you the concept, basic concept, so that you can understand what is happening actually. Why? Like we know this thing that similar charges repel each other, but why? Like why? So there is a question that why. Okay, let me tell you how. So this is outwards. This is also outwards. This is outwards like this. Okay. And this would be like this. Because this this thing is explained in the books, but not the visual explanation is here. Because this visual explanation is part of 12th standard, but I'm telling you in a very simplest manner so that you can understand without any problem. Okay. Like so, and have you studied circle till now? Circle chapter in math? No. So you will understand that okay. So this is the charge. So we are talking about similar charges. It means that there is one more positive charge right over here, placed here, like this. Yes or no? Right. So see this thing that if I take this charge, if I take this thing, so this is like they are in opposite direction. This field is going in this direction. This charge field is going in this direction. Yes or no? They are in opposite direction. If I basically move towards it, this charge will say, okay, please go in that side. And this charge will say, please go in that side. They are basically pushing each other. They are not attracting, they are pushing. They are saying that go on that side. This one is saying go in this side. This one is saying go in this side. So there is a mismatch. They are in opposite direction. That's why we say this thing that the similar charges repel each other. Because the fields are in opposite direction. The field lines are in opposite direction. The electric force is also in the opposite direction. Am I clear to all of you? Just see this thing. Like no need to write all the things, but I'm telling you through the figure so that you can understand. Because this is not a part of your syllabus. I'm telling you how to visualize this thing. Am I clear? Maria, Aisha, Zainab, and Abdul. Okay. So if somebody says that why do similar charges repel each other? Because the electric field lines are opposite to each other. So that's why they experience the opposite forces. So that's why they repel each other. Okay. In a simple way. Next is opposite charges attract each other. So these are the properties. Okay, everyone. So these are the characteristics and properties. If the question comes into the exam that write the properties of the electric charge, so you will write these points. No need to draw the figure. This is just for the visualization. Okay, so you don't need to draw the figure in the exam. Okay, so this is just for the explanation for the understanding. Okay, so let's suppose that I'm basically pasting here. So positive charge is placed. We are talking about the opposite charge. Opposite charge means one charge would be positive, another charge would be negative. Clear, everyone? Okay.
Yes.
Chalo, great. Next charge I'm going to place over here is, okay, that would be negative of charge. So basically, the negative charge electric field is towards the charge, like it is going away, but the electric field charge for the electric field line for the negative charge would be towards the charge, like this, right? Because the bookish word like are not enough to explain this concept, so that's why visualization is a little bit important. Okay, so this figure is still missing in the books, but it's like it can be easily explained for to the 10th standard. So okay, sure. That's cool. As you can see that electric field lines for the negative charge is towards the charge. Okay, inward. Basically, it's inward. So everyone see this thing that if I take this charge towards the negative charge, see this thing that this line is also pointing towards this direction, right direction, and this line is also pointing towards the right direction. It means that they are in same direction. So it means that ultimately they are just nothing but they are attracting each other. It's not repelling. It's saying that if you are coming in this way, okay, you can come. You can come. Negative charge is saying to the positive charge that you can come because the lines are basically aligning to each other. Am I clear, everyone?
Yes.
No need to. I'm just telling you about the like one line because electric this force is a vector quantity. So we'll study this thing in very detail in the 12th standard. But I'm just telling you for the one this thing so that you can easily visualize. Please do let me know, everyone, if it's clear to you or not, that
Yes.
how the opposite charge attract each other. Is there anyone who is having doubt till now? Aisha, Mariam, Zainab, and Atul.
No, sir.
Okay? Clear? है? Chalo. Okay, that's why the electric charge, that's how the opposite charge attract each other and the similar charges repel each other. Okay? Next thing. The next you can say the property is electric charge is quantized. Have you ever heard the word quantized? Anyone?
No.
So quantized word is a little bit difficult to understand, but in a simple manner, it says that electric charge is basically exists in the basically in the integral form, integral multiple. It means that it cannot exist as a fractional. It cannot exist as a fraction or negative. It can only exist as an integral multiple, right? So
So,
the
what is integral multiple?
integral. I'm just saying. Just a second. Integral multiple means the whole number. ठीक है? Integral multiple. It can only exist as a complete number. It cannot exist as a fraction or negative. It starts from 1, 2, and it basically goes till point infinity. Okay? So that this is very important quantity. It tells you that how many electrons are. It basically see this thing that if charge is there, it is any number of electrons and the electric charge means that electric charge would be present in the natural basically the integral multiple. It means that there will not be any fraction, there will not be any negative number, but it will be the basically your positive natural, oh, sorry, your whole number. Okay? And into E. It means that the number of electrons can only exist as a complete number instead of fraction or negative. Okay, everyone?
So how would you define it in like term in a term.
No need to, you don't have to define it. You just have to tell that electric charge is quantized.
So is that like the SI unit?
No, it's not SI, it's the property. SI unit is not, this is not SI unit, this is the property. Quantized means it is a fixed number. It can only exist as a number. It cannot exist as a fraction. Electrons cannot exist as a fraction. You cannot say that 1.5 electrons are there. You can say that only 1 electron, 2 electrons, 3 electron, 100 electron, 200. So numbers, complete whole numbers are associated. So that is what quantized means. It means that whole number, only a complete number is there. It cannot be fraction. Clear, everyone? Aisha, Mariam, Zainab, Abdul. Clear, Zainab? Mariam, your voice is not coming. Please check your mic as well. It seems like you're having a problem in your device. Please check your device. No voice from your side, Mariam.
Sir, now clear.
Now I think.
Sir, I understood.
Sir, what is E?
Yes, what is
E.
E or Q?
Yes. No, E.
E is the electron. E is basically denoting electron. Okay. So let me, Q is, and is this? Q is basically your electric charge. Okay, and E is the electron.
Will we be needing this formula?
This formula, yes, you require this formula. Marissa. We'll do the question based on this as well. Okay. Next is, now let me tell you some basic values, and these values should be, okay, sometimes in the exam, sometimes they give the values, but sometimes they do not give the value. So these values should be on your fingertips, right? So first of all, the charge of electron. One electron charge on one electron is equals to negative of 1.6 into 10 to the power minus 19 coulomb. I will basically SI unit, I'll just forward to write it. So basically I'll write it in the next step. So coulomb is the SI unit for the electric charge. So one electron possesses this amount of charge on it. 1.6 into 10 to the power minus 19 coulomb. Clear, everyone? Next is charge on one proton. So proton and electrons are same in charges. It means that the positive of the electron is nothing but proton. So charge on one proton is 1.6 minus 10 to the power 19 coulomb. So charge on one proton is 1.6 into 10 to the power minus 19 coulomb. Am I clear, Zainab, Aisha, and Mariam, and Abdul? Okay. Next is, okay, but they do differ in the masses. Electron is a smaller, you can say it's a smaller thing. It's smaller as compared to proton. Okay. Mass of electron is 9.1 into 10 to the power minus 31 kg. Okay. And mass of proton,
So is that 31 that you wrote?
yes, it's 31, then 1.67 into 10 to the power minus 27 kg. This is the mass of the proton. So these are the terms you should remember, right? So it's not for the rectification, but for the knowledge. It's just for the, because sometimes in the exams it's not given, but there are questions based on that sometimes. So you just have to memorize these things, right? So these are very basic numbers that should be on your fingertips. Okay, I just forgot to wrote it. So that is SI unit. coulomb. Clear, Mariam, Aisha, Zainab, and Abdul? This is the SI unit of the charge, electric charge. Clear, everyone?
Yes.
Sure.
Yes, sir.
Okay, now let's do one question based on the quantization of charge. We'll study quantization. How many of you are going to willing to take science in the 11th standard? Okay, Zainab, Aisha, will you take science?
Yes, sir.
Okay, Mariam, what about you?
Yes, sir.
Okay, Abdul,
Yes.
okay, that's great. So you will study the quantization in the chemistry, structure of atoms. You will study about the, you can say the quantization of basically quantum numbers, quantization of charge, you can say like particle nature of light. So you'll study that thing. So in that, the quantization of charge is going to be there. Okay. So let's do this question, everyone. So this question is saying that, just a second, let me have a sip of water. Yeah. So let's see. The question is saying that calculate the number of electrons constituting 1 coulomb of charge. It means that the question is asking that how many electrons are there in 1 coulomb of charge. So let's find it out. So charge given is 1 coulomb, everyone, yes or no? And charge on one electron would be 1.6 into 10 to the power minus 19 coulomb, right? Okay, in this question, we are going to ignore the negative sign because we need to find the number, and number cannot be negative. So that's why we are ignoring that. So if we talk about the magnitude, the magnitude is 1.6, right? That is coulomb. Okay. Now let's apply the formula. That is Q is equals to NE. Okay. So let's use that is 1 is equals to N into 1.6 into 10 to the power minus 19. Okay. So, so as you can see, this thing, I need to find the number. So I will basically shift that 1.6 on the left hand side. Right. So I'll take the variable on one side and take the new constant on one. So that would be divided by, oh sorry, it would be 1. So this 10 to the power minus 19 will become positive if I take that in the numerator, yes or no, everyone? So that would be 1 into, so this would become 10. So I'm going to replace this decimal. So this would become 10 by 16 into 10 to the power 19. So basically, if you ignore, basically, if you divide this thing, so this term is going to be 0.625. If you divide 10 by 16, it's coming out to be 0.625 into 10 to the power 19. So I'm taking 110 from this side, so that would become n is equals to 6.25 into 10 to the power 18 number of electrons are there in 1 coulomb of charge. How many electrons? 6.25. So now you will say this thing, sir, you just told us that number of electrons cannot be decimal, cannot be fractional, but here it is. But the thing is that, Bacho, if you take 100 from this, so it will become 10 to the power 16 and multiply this 100, so this decimal will diminish. So what will there? 625 into 10 to the power 16. So that is a complete number, whole number, yes or no, everyone? This
Yes.
is just the shortest form. So that's why decimal is present. That doesn't mean that that doesn't mean that it is not integral. It is integral. Okay? So that's why it's important to basically know the number, know this number specifically. So in the MCQ question, there could be a question that what is the number of electrons present in 1 coulomb of charge? So it could be written as this, like this, it could be written as like this, or it could be written as 625 into 10 to the power 16 number of electrons. It can be written as like this. right? So 1 coulomb of charge consists of 10 to the power 625 into 10 to the power 16 number of electrons. Am I clear to all of you, bacho, everyone?
Yes.
Any doubt so far to anyone?
So is there a unit for this?
No, the number of electrons. Number of electrons is it's this number. Okay. So let me write one thing. 1 coulomb of charge is equivalent to the charge contained into 10 to the power 18 number of electrons. Okay. This is a very important number for the question point of view. Okay. So question could be there based on this thing. Please do let me know everyone if it's clear to you or not. Is there anyone who is having doubt till now? Please do let me know everyone. Aisha, Mariam, Zainab, and Abdul.
Sure.
Clear? These are the basic properties of the electric charge. Okay? Please do let me know everyone if it's clear to you till now. Anyone is having doubt? Okay, this is just for the explanation so that you can understand why do we say that a similar charge is repel each other and opposite charge is attract each other. Okay? This is just for the explanation. So you can skip for the exam. Right? I've just explained. Okay? Chalo, that's it. Okay. Now let's discuss another topic that is conductors, insulators. Can anybody tell me what do you mean by conductors and what do you mean by insulators?
Materials through which electricity can pass through,
Hmm.
and
Okay,
then
those are called conductors or insulators.
conductors are the ones in which electricity can pass through.
What about insulators then?
Those are the materials through which electricity are not able to pass through.
Okay, ठीक है. Anyone else? Mariam, Aisha, and Abdul. Zainab said, this is Zainab given the explanation. Anyone else would like to add something in it? Okay, after this class, there will be an assessment, so please do not forget to check it out. Okay? Okay, no one else. Chalo, ठीक है, let me tell you. Yeah, Zainab already like said absolutely right. So the materials which allow the electric current or electric charges to flow are called conductors, and materials which do not allow the electric charge or electric current to flow through it, that is called insulator, right? So let's understand it. Okay? So basically, in the exam, there could be a question about same, that what is conductor, what is insulator. Okay? Or material allowing the to it are called conductors. Okay. B is, so basically B point means the examples of conductors could be metals. Metals are the very basically the common examples of the conductors, right? And one more like example for the conductor is graphite. So how many of you have studied the carbon compound chapter till now? Carbon compound, fourth chapter of chemistry in physics in the science 10th class.
We just started it. We didn't finish it
Ajay.
yet.
So basically, we'll study that in the allotropes of carbon, the last portion of this chapter. We'll study this thing that graphite can conduct electricity even it's a non-metal. Why? The reason is that graphite is in layer form shape. The layers are there. The structure of the graphite is in a layer form shape. Okay. So that's why it could basically allow the electricity to flow through it, through the layer. So that's why graphite is also an example of the conductor of electricity, even though basically it's a non-metal. Okay. So metal is very common example, but graphite as a non-metal is also an example for the conductors. Okay. Metal and graphite. Okay.
Graphite is an exception, right?
Graphite is. Okay. Metals and these are very. Okay. So let me tell you that most of the things are made up of metals as a conductor. So we must have seen this thing that in the household wire is made up of metal. So basically, if you basically remove the plastic covering of the wire, so you will find out that there is a brownish color metal present in between the wire that is called copper wire. See this thing that this is the material, this is the plastic covering. So if you remove that plastic covering, so there are very fine wires, very small, very thin wires because of the ductility. Ductility is the property of a metal. It means that it can be drawn into wire. Ductility is used for that. Malleability is for the sheet. Like metals can be, you can say, transformed into sheet, right? So that is the thing. So these are called copper wire. Okay, so copper wire is used as the conductor. As you can see, this is a plug. So in which metal pins are used as the conductor. It allows the electricity to flow. It completes the circuit, right, everyone? Okay. So plastic covering or the insulator is used just to protect it from the water, heat, and any other external, you can say, thing. Okay. This is the thing. Clear, everyone? Next is insulator. Okay. So insulators are those substances that basically which do not allow the electricity to flow through it. Okay. Insulator. Okay. B part of the insulator would be that insulators, so you can say the example for the insulators are wood, plastic, rubber. So as you can see this thing that we do not basically that basically your plastic like see this thing that this switch is this plug is made up of plastic. So because it is insulator, so it does not allow the electricity to flow through it. So that's why we can easily handle this plug while basically inserting it into the socket. Yes or no, everyone? And like you must have seen that basically if there is something that which is not good in the electric board, so we use wooden stick to close the basically open the circuit, right? It's advisable to use basically you can say wooden or plastic or rubber thing so that electric current does not flow through it. Okay? So non-metal, all the non-metal except graphite. Okay? So in that case, non-metal, rubber, wood are good insulators.
But then doesn't rubber and wood already count in non-metal category?
I didn't get your words, Zana. Please repeat.
But then, like, doesn't wood and rubber already include in the non-metal category?
You can assume this in a very general manner. You can assume, and if you want to like a little bit exaggerate, so that teacher will say, "Yeah, student has written something in the answer," so that you can use as the exaggerated sequence. We can say expression, right? So it's up to you. If you write it, non-metals are very good example of insulators. That is also good. If you write non-metals, rubber and wood, just to showcase it. Okay, so that is all things acceptable. Am I clear to all of you? Please do let me know, everyone. Right? Mica, stone, okay, cement, and these are the examples of the insulators. Okay, that's it. Acha, everyone, please tell me that what is the like how do we consider that which substance is a conductor and which substance is an insulator? Can anybody tell me? Acha, I'm giving you a hint. A hint would be that like it depends on the valence electron. In the ninth standard, there was a chapter atom and molecules, in which you have studied valency, valence electrons, loosely bounded electrons. Yes or no? Remember? Okay, so this is the hint. Tell me, how do we consider that whether the material is a conductor or it's a insulator? It's an insulator.
See the valency of the
Tell me.
like,
Yeah.
we see the valency of the element, and then we come to know that whether it's a metal or non-metal. And then through that we come to know if it's insulator or conductor.
I didn't get it. Could you please a little bit explain a little bit more, Zana, so that in a very simple manner, like what you're trying to say. Just say it in your language. I don't need any kind of very scientific or very defined language. In the normal language, just explain it to me. Just like you explain to your friend.
I don't know how to furthermore explain it.
Okay, explain the same thing that you have just said.
Okay, so if like there's any element,
Hmm.
we see its valency, and then we come to know whether it is a non-metal or a metal,
Hmm.
and through that we come to know whether it is an insulator or a conductor.
But one more thing, if I just counter this thing, that there is a, you can say, element that has plus four, you can say, valency. That is carbon. Plus four. Carbon can attain plus four valency as well, but still a non-metal. That plus four is the valency of plus is the valency of the metal.
It will share its electrons, right?
It will share its electron. Okay, carbon. Okay, ठीक है. We'll explain. Aisha, would you like to add something, or would you like to basically define something else?
No,
No? Mariam? Mariam? Abdul? Abdul, are you there?
Yes.
I'm saying, would you like to basically define the question? Basically, like, how do we get to know that whether a material is a conductor or not?
Mm.
Yes, Abdul, tell me. No idea.
Mm.
Chalo. Yeah. So Zanab was, you were like, you can say like a little bit more close to the exact answer, but not that much accurate. So basically, the free electron tells you, the explanation was like the word that you use a little bit confusing. The way of explaining a little bit confusing, so that the accuracy was not there. So if you say this thing, the free electron of a material will tell you whether it's a conductor. It means that they go Na plus one. Plus one is the valency of the sodium. It means that it is the metal. Al plus three. Al plus 3 means three electrons are loosely bounded. So loosely bounded, those electrons that are loosely bounded are not affected by the nucleus, are not attracted by the nucleus, like as compared to the like nearer electrons. So those electrons can basically come out from the shell, right? So that's why. So that's how we basically, we can say the consider those materials as the conductor. Okay. So let me write it over here. Because ultimately, if we talk about the electric current, so electric current is just nothing but the flow of electric charges. Yes or no, everyone? Electric current is the flow of electric charges. So if there are charges in the, so that's how the current will flow. If there are no charges, so no current will flow through it. Okay. The presence of substance makes it a conductor of electricity. Where everyone, please do let me know.
Yes.
Anyone who is having doubt till now. Right. So this is the basic thing that you should understand, that free electrons should be there to be considered or to be basically classify as the conductor. If there are, so basically in the wood, in the non-metal, no free electrons are there. All the electrons are very tightly bounded with the nucleus, right? So that's why they can only accept the electron instead of below, basically just uh, going throwing away, right? So that's why that's why they cannot be considered as the, can say, a conductor. Okay. A free electrons is the condition to be considered as the conductor of electron. Am I clear to all of you? Please do let me know, everyone.
Yes.
Any doubt so far to anyone? Just a moment. Let me check if there are any questions. Okay, I just wanted to really one more thing as well. Let's check it. The thing that I wanted to say is that, so basically in electricity, so there are two types of electricity. So first type of electricity is called static electricity. So static electricity means that, suppose that you basically rub a foam in your dry hair, so, right? So and if you basically take that foam near to the balloon, so that foam will basically attract the balloon. And balloon will get basically you can say attached to the form because of the opposite charges formed when you rub that on your hair, when you rub the form on your hair. So that type of electricity is called static electricity. It means that basically charge are induced. Inducement charge are produced by basically some kind of process like rubbing, or by, you can say rubbing, or you can say only rubbing is the basically most common thing, right? But in the case when the charges are flowing through a conductor, right? So flow of charges causes the flow of current, electricity production. So that type of electricity is called dynamic electricity or current electricity. Current means a flow is there, right? So we use the word current in the water. Current in the water means that flow of water. It doesn't mean that electricity is flowing through the water. Yeah. So it's the current in the water means the current in the water means there is some wave, there is some motion in the water. It's not still water, right? So that's why this type of electricity in which electrons are flowing through the conductor due to which the electricity is produced, is generated. That type of electricity is called current electricity or dynamic electricity. Okay, clear everyone? So okay, so we are going to study the dynamic the current electricity, or you can say dynamic electricity, because the electric charge will be flowing through the conductor. Clear everyone? Right. So, chalo, that's great. So let me check if there are more questions based on the same. What is the SI unit of electric charge? Maria,
Coulombs.
Maishi, Dana. Yes, yes, Dana.
Coulombs.
Okay. It's not Coulomb, it's Coulomb. Coulomb.
Coulombs.
Okay. Chalo, that's great. I don't think that there is any question left. Or other than this question. Do let me know the answer for this question in a chat, not orally in the chat. Okay, Aisha. Mariam and Zainab. Okay, then. Uh, Zainab, it is D option. How did you say B?
Yeah, I messed it up. I just saw it.
6.25. It's written over here, na? 6.25. It is completely divisible by 10.
Yeah.
Sorry, 16. 10 by 16, na? So they both are completely divisible because both are the multiple of 2, right? So if you completely divide it, so it would become 10, 6.25 into 10 to the power 18, not 6.2.
Yeah.
Okay, so that's why this number is very important. So this could be a 1 marker MCQ in your exam, that what is the charge equivalent to like how many, like 1 coulomb is equivalent to how many electrons. So this number of electrons are required to basically equal to the 1 coulomb of charge. Am I clear to all of you? Please do let me know, Maria, Maisha, and Zanab.
Yes.
Okay, so in the next class, basically we are going to start the potential difference and the electric potential. So that's going to be a very important class for all of you. Okay, so please do not miss the classes. Okay, please be consistent. I know that exams are happening right now, but you have to be